Well, g'day, welcome back to the shed, and today I've got this Admiral Transistor 8 which I bought a little while ago. Now you may remember I did a video on a blue coloured one of these, or turquoise. That was repair for its owner and I had to give it back reluctantly, but I thought, well, if one comes up for sale I'd grab it. Sure enough, a few days later this one was advertised on Facebook Marketplace, so I picked it up. Now it's the same model. This one is, according to Radio Museum, Arizona Tan. The other one was called Turquoise, and they also came in red and yellow. I'm not sure what the colours were called. I don't know if I'd call that Arizona Tan. It's more of a nipple pink if you ask me, but anyway, it's not too bad. Now it is a bit more knocked about than the other one, unfortunately. A few things. This aerial is supposed to click in and lock. It doesn't. And there's a few other bits and pieces that will need fixing up on it, but I'm sure I'll get it going. At least, well, I shouldn't say that, should I? I hope I'll get it going. We'll see how we go with it. So let's get into it and have a look. So the first thing I noticed about this is that the screw that holds the chassis in the cabinet is broken. It came straight out. It's got this brass washer which fortunately hasn't been lost. But that means that this is no longer held on the way it should be, and the owner told me that someone put Velcro in the bottom of it to hold it together, which is not a great idea, I don't think, because it's not going to come out without a fight. Well, the speaker looks alright, at least, so you can probably see the strip of Velcro in the bottom of the case there. Just looking at this cabinet, the grille cloth is coming off along there, and the whole lot seems to have shrunk a bit. I can hopefully get that looking a little bit better. It's a little bit ragged along the edge here. I might be able to glue it back and pull those threads into place. Not too sure. Other than that, it's pretty much intact. The chassis is the same as the other one. It's got this dreadful battery holder here, although this one seems to be in better condition than the first one I looked at. It's obviously held together with a piece of wire here, and it's broken on the top there, so a few more repairs necessary there. I also noticed a small chip on the handle here, which maybe I can do something with, maybe not. I'm not sure whether it will be better to leave that alone or to try and fix it. It's only a small chip, but it does detract from the overall appearance. And of course there's this thing here. But more to the point, I'm told it doesn't work. I don't know if it's got batteries in it or not. I hope not, because they will have corroded. No, it's got no batteries in there. Otherwise I would expect to find the springs all corroded up. I'll take this off just for the moment, just see what it looks like inside. Oh, they're pretty dirty. Someone's had a go at soldering that with something pretty agricultural. And from what I can see looking down it, the springs are not too bad, but I'll pull that off. And it looks like there might have been some screws in the end that held the springs in. I don't know. So that's another job. This will be another one. Now fortunately I did have the other radio still with me when I first picked this up, and I was able to get a good look at the screw that holds the chassis in, and took photos of it and measurements. Now this is nylon. Will be difficult to, at least I think it's nylon, will be difficult to get anything to stick to it, but I'm hoping that I can make some sort of repair so we can use this as it was intended. I don't really want to go with that Velcro idea. In fact, I'm going to peel it off now because it's just a nuisance, and it stops the radio from sitting flat on the bench. Oh, probably so will this. So, looking at it, there's a bit of corrosion there on this transformer. Other than that, doesn't look too bad. Original electrolytics all over the place. No one's been in here or done anything with it. I suspect they'll all be leaky. Oh, and look at the soldering on this. Oh my god, someone's had a go at this. Just looking at the volume pot here, there's solder all over the place here. It's dripped down over the pot. There's a pool of it in the bottom there. So someone's had a go at fixing it with without great soldering skills by the looks of it. Now to fix this pop-up aerial catch, I'm going to have to disconnect the aerial anyway. That will make it a lot easier to get at this circuit board and change the caps, which I'm sure I'll have to do and test it. But before I do that, I might just hook it up to the power and see if it does anything at all. I'm just going to check the red wire to ground. Yep. Yeah, so it's positive to ground. I guess the red wire is the positive. Okay, so hooking the power supply up to it. And it's got 12 volts going in. Let's turn it on and whoa! Gee, that's pulling some current. I don't know if there's anything cooking in here. I'm not hearing a lot. I thought I heard a crackle. Just give it a little bit more current. Bring it up. That's 11 volts there. I don't like this. Ah, there's some noise. That sounded like reception, but it disappears. I'll stand it up, see if that helps. Yeah, no, I can smell something getting hot. Did get a sniff of reception there though. I did hear sound from the speaker, but I'm not going to push it because something's going to go bang, I think, if I keep pushing power into it. So we'll leave well enough alone for the moment, I think. I wonder if anything's getting hot there. Can't really tell at the moment. It is an advantage having worked on one of these recently. I remember how to pull it apart at least, and appearances can be deceptive. It looks as if you just take out these two screws and the corresponding ones on the other side and lift the top off, but it isn't quite that simple as I recall. Anyway, I'm sure you don't want to watch me wind these screws out slowly, so I'll come back when I've got them out. Okay, so with the screws out, I should be able to lift this up, but you'll notice the antenna wires are connected here and it doesn't go much further than that. We do have 4 screws in this top foil thing here which need to be taken out. But first I'll just make myself up a little diagram of where all these antenna wire things go and disconnect them, because they will give me untold trouble otherwise. This one's been taped up and soldered on as well. That's a little bit odd. Well, if I push the top up, okay, that's as far as it'll go with those aerial leads, but that's enough. And now, yep, we can see where those wires go. I'll just take a quick photo of that so I remember. So I'm just using my screwdriver to hold up that foil there, and I should be able to get this out. Okay, that's one, and the next one is that big fat black one that's been joined on. Someone has certainly been in here before, that's for sure. Now, the only other one I need to take off is that one off the coil. Gee, I don't want to melt the junction of that fine wire there to the coil. I'll just have to be careful with that. I'd almost prefer to cut it than to desolder it, but here goes. There we go, nice and quick. And of course there's this one onto the frame of the capacitor, so that's going to take a bit of heat. Just see how we go. Melt a little bit of solder onto there to help the heat transfer. Not sure if this is going to actually do it for us. Nope, that's not a soldering iron. This is a soldering iron. And now there's just this one to take off. The little toy one will do for that. Okay, now we should be able to just remove the whole top panel with the aerial, and we've got a ground there off the chassis. Yeah, I'll just do that ground. Come on, there we go. So I'll just take this metal foil off, it'll make things easier to see, I hope. These are already quite loose. Someone's been in here and not even done them up again properly. And just remembering that the earth went on the front right, looking at the back of the radio, so I guess that's back left actually. Here we go. And there's the board, which we might actually be able to remove, but I don't know if we'll have to. Just looking here, we've got several electrolytics. That one there seems to have popped its end out a little bit. There's something in here which is pulling down the power supply, I'm pretty sure. So I'll just have a look. There may be no easy way to find out apart from changing them one by one. I'll have a look at the schematic and pick out the most likely culprits anyway, and we'll go from there, I think. Maybe take them out in order of probability. Okay, now I think to get this board off altogether, I'll just need to take this red lead off here. There we go. It's off the aerial coil. I presume that one here is the oscillator coil. And it should just lift out. The wires around the speaker here look like they will just unhook from around here. So I can leave that in place. Need to loosen that pot and undo the tuning cap. I'll just loosen these off. And coming out nice and easily. And I'll just need to undo this pot from here, and it should just slide out upwards and the tuning cap will just lift out. That's the theory anyway. It should lift out of there. Should, whether it will or not is another matter. Something seems to be holding it. There's a screw, which, like all the others, is loose. Bit of a concern. In the box with it. Now, yes. There we go. Looks like all the transistors are replaced, at least I think so, because these were in sockets on the other one I had, and they're not on this. Oh, look at that, just lying around. Now I don't need to test any of that because we know it makes noises, and we know the oscillator's running because it kind of had reception. I think our problem is with these caps pulling down the power supply. Looking at the prime suspect, I've identified all the electrolytics on this diagram from Radio Museum, And so looking at the schematic, here they are here. Now see 16 and 17, that's these two here. The prime suspects there across the power supply. This is a classic pi filter, it's got a 100 ohm resistor in between. I'm not all that used to working with transistor circuits. I'm surprised they put a pi filter on the battery feed. I would have thought that it would be pretty quiet and stable. Anyway, those two are there, that's a possibility. C22 and 21 are on the driver for the output transistors. That's base to the volume pot, so that's basically audio going through that one. Oh, ran out of battery. Now where were we? This electrolytic here on the collector of this driver transistor, I guess could also have an effect if it was leaky. I'm not sure. These all are capable of messing it up. So look, I think it's just a case of, I'm not going to leave them in there anyway. I'll take them out, replace them one at a time, and just see how bad the old ones are. Okay, I was just about to start desoldering these, but I can't look at this earth connection to the pot without it hurting my eyes, so I'm just going to do something about it first. We'll just get this all this blob off. There we go. Just clean it up a bit anyway. Maybe just trim it off and it'll be alright. The wire is a bit dodgy too. Let's get a bit of solder into that. And just tack it on there. That'll do. Now, these caps, probably the easiest one to get out is this. It's bent over, okay. It's stuck. Okay. I'll just nip the end of him off. So that's that side out. There we go. So, yep, 100 UF at 12.5 volts. And of course it's positive to ground, we don't want to make that mistake. So I'll just get another one. Now this one's 100 UF at 63 volts. And that is the positive, the long wire, so that goes to ground. There we go. I'll actually leave him up a little bit just to make it easy. Alright. So now let's have a look at what it measured. Where is it? Oh, there it is. Hold it up here where you can see it. $204.6 UF. Okay, so it's double its original value. Probably not very healthy. This is not really going to tell you how leaky it is, but from that I would say it's not well anyway. Okay, let's do the other one, the other 100, and these are the two on the battery, which is a little bit odd. There we go, there. And there is a hole there somewhere. There we go. Alright, let's have a look at this one. So it is 201. 201. Much the same story as the other one. I'd say not well at all. Double its value. So we'll just put this one in, another 100 at 63 volts. And that is the positive. Alright, that's those two. Now I've got this other one here, which is also 100. I should check the resistor and across the top of those too. Ooh, I think it's that one just down in behind the pot there. You can hardly see it, but brown, black and brown, so that's 100 ohms. On the schematic, yeah, 100, that one there. I'll see what it measures. Check 0. And this is on the times 10 range, so now where is it? That'll be it. And it is showing just about, well, according to this, 95 or something. Unusual for them to go low, but near enough, I think. Okay, so let's deal with this one. 100 UF, and it's a smaller cap physically, so I guess it's at a lower voltage. That'll be him there. Yeah, the wire's bent over. Okay, so 100 at 3 volts. Really? Oh well. Okay, let's see what he measures. Okay. It's taking its time. A 63 ohm resistor. That's what it was. A 63 ohm resistor. Well, that won't have done it much good. So that was C22, the one on the collector of the driver transistor. Let's see what we've got here. This one's 100 at 16 volts. Alright, that'll do. Alright, we've got a couple of others to go. Over here we've got this one and this little one here. What's this one? This one is .25 UF at 6 volt. Okay, let's have him out. I must say this one is a nice easy radio to work on once you've got it apart. Interesting, these are all axial caps. They can't have been able to get radial electrolytics. Now you can't get axial ones. There we go. He seems to have popped his little bottom out a bit. So 25. That one's a 10. 22 at 63 volts, probably the closest thing I've got. Positive to there, yep. Negative goes through to there. And I'll just melt that a touch to get him in. There we go. Gee, that's got a big hole in it. Doesn't matter. It's well and truly attached there anyway. The solder just isn't going to fill the hole. Okay, and there's this. I'll see what this one is. May as well continue the way we're going. So this one was a resistor. Yeah, 25 UF this one is. Let's just see how it measures. .23 farads. Is that right? Anyway, I'll do that again. I haven't seen it measured anything in farads before. V loss equals 3.8%, ESR 2.7 ohms, 0.2 farads. Alright. Well, I guess it's fair to say this one wasn't very well either. So it's well out of there. And the last one will be this little electro here. Now this one's a 10. Okay, so this one is a 10 and it's in the AGC bus. It says here the positive goes to this side, that long track, and the negative goes there, connected to the base of the transistor. Is that correct? Yeah, that's right, as per the schematic. So the positive goes in the great big hole. And the negative goes to the base of the transistor. Alright, now I do hope these transistors are alright too. That one looks like he was losing his guts as well. So let's check him out. Right, here we go. (2,732 nanofarads). Supposed to be 10 mic. 2.7. Whatever. Now I don't know about these disc capacitors. They're possibly some kind of ceramic disc. There's also this one here, which I'm not sure what it is. It runs across here. This is C24. It's across the two output transistors. Yeah, it's not going to have a lot of voltage on it. Well, the other thing I can do is just go over and check a few random resistors and see how they look. So these should be 15k. 8.7k. 1k. but of course they're in circuit and I'm not sure what we're looking at across them. I'd have to find them on the schematic, and I'm just checking random resistors here. So here's a 1K, 617.6, so 618 ohms, and again it'll be across something, so measuring them in the board is really not a great idea, but they should be at least their value, but they may be under because they're across something. So this, I think, looks like white, brown and red. What's that, 9.1K? It's saying it's open. 10.2K it says. 9.1, that's odd. That's a little bit high, but nothing to worry about. I don't think, of course, in a valve chassis you wouldn't worry about them being out a little bit. With this, I'm not too sure how accurate you have to be. I understand that values are more critical though in a transistor circuit. Nevertheless, look, I might just put this back together to the point where we can fire it up and check some voltages. What we need to hook up is the aerial, and I was going to see if I can sort this aerial clip thing out. I will take this out of here now and see if I can come up with a solution to the latching of this aerial too. Okay, so we've got this circlip on here, so I guess the obvious thing to do is to remove it. And we'll see what happens then. Now, it does want to lift out, but of course the handle's in the way, and we've got a spring there. I might have to take this handle out. It appears to be just a couple of screws in here, so I'll do that. So there we go, handle comes off. It looks like it's been broken. It's been cracked across here and glued back together. I'll see if I can clean that off and smooth it over so you don't see the break. Now, the rotoscope it's called, this aerial, and there we are. Just feed its little wires through the hole, and it's got a spring on it. Now, what makes this lock in? I can't see anything. Perhaps it grips up the top there. We have this grippy thing here, and this is off center, so I can't turn all the way around. That should catch underneath there, I think. Obviously it doesn't. Possibly just doesn't push down far enough. Maybe the spring's in the way. With that pushed right down, it could lock into there. There's a little shoulder on it. I'll have a look at that later on anyway. I want to get the thing going at the moment. And now I'll have to refer to my previous drawings, I guess, and find out just how this was connected up. Okay, I've hooked these aerial wires up as per my photos that I took before. This blue one won't reach to the aerial coil there, so I've just had to jumper a bit into it. And I guess that'll detune the circuit a little bit, but I don't want to put it back in the chassis at the moment. It should still work, if it's going to work at all. So now, I guess we want some voltage on here. Put the positive to the red wire here, negative to here, which actually is the hot in that sense. This aerial, I guess, well, we'll see what happens. So, I want some voltage on it here. Output is off. Put that there and set it to, yeah, 12 volts. It's 12 there. I think the pots on this are a little bit dodgy, but I've never been able to get the knobs off this to take them out and clean them. I don't know why. They seem to be in with something like a 1mm Allen key. Anyway, the switch is currently off. I'm going to put this on. Now that switch doesn't seem to be working. It's on all the time, I think. We've got some noise there. I'll actually put a knob on this because it's really hard to turn this tuning cap. We do seem to be getting reception there, but it's not very loud. Well, it's definitely reception, but it's not good. Just feeling for anything getting hot here. Well, that's not very much improvement. Yes, we are getting very faint reception, and it does tune stations. But there's something not right here. Oh, that transistor is really hot. Okay. And I notice it's got the paint burned off it. That might be a good place to start looking. The other one isn't. Only that one. Okay, so that is Q7, one half of the output pair. Now, the emitters should be at ground, 0 volts, should have minus 11.9 on the collectors of both of them, and it should be a 2N270. Now, I don't know what it is. These have been replaced. Hopefully it is a 2N270, I don't know, but we'll have a look. Of course, the paint's all burnt off it and presumably the writing, but whatever the other one is, this will be the same. I don't know if I can see it there though. Looks like there's an SFT 153. I'm not familiar with these things, but that's an SFT 107, SFT 153. Don't know what that one is. SFT 108, 107, that's an SFT 153, so I guess they're both the same. And interestingly, that resistor near it looks pretty cooked. What's that one? It looks like, is that yellow? Yellow, violet, and ooh, that third colour could be anything. I'm probably going to have to go to the schematic and work out what that is. Okay, so that resistor that's burnt, R23, and it does go to the emitters of both of these transistors. So that looks about right. So I guess we pull this out and see if I can, I'm going to have to replace the pair of them obviously, see if there's anything else cooked. Hopefully not. It's fried that resistor, but this capacitor's possibly alright. Shouldn't have any voltage across it. I'm hoping the output transformer's alright. Okay, so I've taken it out. Let's just put it in our little Chinese box of wisdom and see what it says. "189 ohm resistor." Now I have 0 stock of transistors because I don't normally work on them, apart from a few little silicon NPNs that I bought for another project, and that's long ago and not going to be suitable in any way. So I'm just going to have to buy something suitable, I guess. Well, it's the next morning and I've done a little bit of research. The only 2N270 transistors that I can get are in America and they're going to cost me the best part of $100 by the time I get them, which would be in a month or two's time. So that's not going to happen. I was able to order a couple of AC 128s locally for considerably less money, but still not cheap, and they will probably still also take a couple of weeks to get here because they're on the other side of Australia. So what have I got at the moment? Well, I've been down to the local electronics shop and got a couple of P&P silicon transistors, BC559s. They might work, they might not, but in the meantime I'm going to give it a go. Now, I cut the legs off that transistor to get it out, so first of all I'll just have to get out the legs. Come on, out you come. There's one. And of course clear the holes in the board, and of course I'll have to replace both of them because they're push-pull pair. Where are we? There's another leg. I'll check the components around them too, because of course I still have no idea why that transistor failed. It may have just failed spontaneously, but gee, I don't know. I'll check the other one of course as well, see how healthy it is, but this is the one that was getting hot. Now the tracks on this board are suffering a bit from being soldered and resoldered, and I could check this capacitor, which is across the two collectors and across the output transformer of course. A lot of blobby solder on there, but I can probably get it out. At least lift one pin to check it, but I think it'd be easier to take the lot out. Okay, so let's just unsolder him. I'll do this while there's no transistor in there to overheat. Alright, I should be able to bend those pins up now and get this out of the way. That's one side. That's the other side. Come on, out you come. There we go. And that track just is lifting anyway. Okay, come out, come out. There we go. Alright, let's see what we got here. Ducon cap 0.047 UF at 200 volts. Let's just see what happens if I stick him in here, and I can probably just put it in, maybe. No, I'll have to attach some leads. Okay, here we are. I've got him hooked up. 135.6 nanofarads. So that's that 0.13 UF. I don't think it's terribly critical in that location, but I'll put another 0.047 back in it. Okay, so I've got one of Carl's finest 0.047s, so I'll just slot that back in there. Way over spec for this of course, but now will that fit in that way? Of course it's axial, not radial, so it doesn't fit in particularly well either way. Probably better the other way actually. I'll just bend the leads a little bit and I think it'll be fine. Yep, that's fine. That'll do. Solder him in there. There we go. Alright. Now the only other thing I want to check before I put the transistor in is this 47 ohm resistor on the emitters. That looked a bit cooked. Not surprisingly, since the transistor was pretty much shorted. So that's it there. And it doesn't look terribly well. The third band on it is unreadable. It's pretty much burnt off, so I didn't know what it was without checking the schematic. Anyway, we'll have it out and see how it measures. Okay, so that's him there. See if I can lift the lead on it without damaging anything too much. That's that end. There we go. And it measures, let's see, 5.1 ohms. It's probably not too good. Anyway, I should have a 47 ohm resistor lying around somewhere. And this one, just to check it, measures 47.3 or 4. All right. So the left hand one is the collector, apparently, so that will go in this way. I bought 10 of these, and I picked 2 with identical HFE readings, so hopefully they'll be all right, if they work at all, of course, which is, well, far from a foregone conclusion. They may do nothing. Being silicon transistors, they might not like the biasing arrangement. They're looking for a higher base emitter voltage, I think, than what we've got. But we'll see what happens. They'll go bang, or they'll not work at all, or maybe they'll work. So that's a 33.3% chance of or probability of it working. Okay, so this one seems to have the best pad on it. I'll just tack that on. There you go. This one I'll bend over a little bit. Yeah. There you go. Quickly. Yeah. And where's the other one? There. Okay. Well, that's as good as it's going to get. I guess I'll do the other transistor, and we'll apply some power and just see what happens. Of course, this may not be the only fault with this board either, but we'll take this one out and see how it measures, just out of curiosity. Well, there he is. Got him out without having to cut anything. I'll just see what that measures. 2 diodes. Well, that's kind of right. Okay, that last transistor I pulled out wasn't the other half of the push-pull pair, it was the driver. My mistake. I didn't realise till I was looking at the connections on the board and scratching my head about why it didn't seem to make sense. So there it is there. I put it back in. I'm a bit worried that it tested as 2 diodes on this tester here, but I suspect this is set up for silicon transistors. It doesn't really like looking at germanium, perhaps. Anyway, the real other half of the output push-pull pair came from here, and it was this 2N217S. Now, it's still not the original type, and I suspect it's been replaced. I'll see how it checks out. I'll take that light off, it might make it easier to see. 2 diodes. Gee, what a configuration that is. Anyway, I suspect it's actually a transistor. I'll keep it. Maybe I'll try testing it on something else. So the collector will go to the output transformer here, that's right. and to one side of that cap. That's correct. Base goes to the transformer and the emitter to, now on here there's a link from here to here, so it goes to the other emitter and that resistor which I replaced. Yep, that's fine, that's right. Okay, well, let's just see how we go. I've connected the aerial up again in the faint hope that maybe it'll work. Put the power supply on here. Let's just come off, that will probably do. And onto here. Now this will either go bang or not work at all, or there's a very slight hope that it may work to some extent. Anyway, power is on. I'll set that to 12 volts. Actually, I'll set it to 10 because I don't really want any more than I need to. And power is on. Bloody hell.
Harry Edwards, the bench, so I suspect he's the man being subbed out here for the West Coast.
It was a great contest from Archer. Police say the ban on release action firearms will begin tomorrow, and anyone with that type of gun must...
Sounds pretty distorted. It started off fine. Now it seems like something's cooking. What's... Okay, look, I'll put it on again, see what's going on. I'll put 8 volts on it.
But the man hasn't yet been. John say they take the woman, both in their 20s, to Karnak.
His first goal was a beautiful shot, an absolute beauty. In his final 5 minutes.
Well, it's working, but very distorted, and I suspect it's because those silicon transistors are just not up to the job. I don't know what I can do to change it. I could fiddle with the bias values. Have to have a look at how you would do that, or I can wait for the germanium transistors to come in and substitute them, see if that makes any improvement. Now I'm looking at how these transistors are set up. R24 says 100 ohms, but in fact it says down here R24 was changed from 100 ohms to 270 ohms, shunted by a 350 ohm negative temperature coefficient resistor. Now that calculates out to be 152 ohms, not accounting for the temperature, the resistance change for temperature. So that's 152 across there. Now looking at it, you've got B plus coming down here, goes through the center tap here, along here. So this is B plus. This is the hot line here. Don't worry about that, they don't connect. That goes up through the primary to the collector of the driver, so that all makes sense, almost like a valve circuit. Now the collectors run through this 47 ohm resistor here, which had been running hot, and we've got B plus coming up to, and I don't think that connects there, I think that goes around to the center tap here. Now the voltage on that center tap is going to be controlled by this resistor here, and also from this 350 ohm resistor here. That goes straight to ground. So basically you've got B plus here to ground here, so this more or less forms a voltage divider network with the center tap of this coupling transformer in the middle of it. So I was thinking that sets effectively the voltage difference between the emitter and the base. So if I change that resistance, maybe put some more in there, I could increase the emitter base voltage. Now it says here minus 0.16 volts. A bit hard to read, but it's definitely 0.16. Now, bearing in mind silicon transistors have a bigger junction resistance, you would need a higher voltage across the base and emitter in order to function, or you'd only get half the waveform. My theory is that that's what's happening, and it's only a theory and I have no idea what I'm doing. But I was thinking of playing with this and putting in perhaps a larger resistor here. So let's just see what happens with that. I may blow the thing to smithereens, but gee, you gotta try something sometimes. Okay, this is a bit of a butcher's job, but I'm really just mucking around. I've lifted one half or one side of that resistor. This is the net 152 ohm one, the R24, 270 shunted with a negative coefficient resistor, and that's it there, I guess. Now, I figured we've got 12 volts on one side, we've got an 11k resistor, or 11k resistor in series with that, and then this to the center tap of the transformer. So about a k would give you an extra volt perhaps. So I thought I've just got a 1k resistor just tacked on there, goes through the board and it's tacked on there. So let's see if this goes bang. It might work and it might be worse, we'll see. So turning on.
How do you see the role and importance of that concept of truth-telling, which was one of the elements of the Uluru Statement from the Heart?
Oh, look, truth-telling is crucial. It's critical in every aspect of life, and I think it's really critical for this country right now.
Well, that's a lot better.
You know, growing up, I was told about Aboriginal history of Australia from my family. Then I went to school and I was told something completely different. And back at university, you know, things are changing in that regard. You know, more and more curriculum.
There's still a bit of distortion there, I think. But maybe I'm on the right track with this. I might just fiddle around with values here and see if I can get it any better. Okay, so
Wales, Central West,
I've
and it was this
just stop that.
Auntie Joyce Williams, and
I've put in a 1.5k resistor here, and that sounds excellent.
quite
turning it
elderly,
on.
so we didn't know how much time she had, and I was lucky enough to go out to our Dubbo office, meet her in Wellington, and just capture her live and just the impact that she's had.
I can't really hear any distortion there. I can still fiddle with this a bit, I suppose. Now, the other thing is I've already ordered some germanium transistors, AC128s, I think they were, online, and they might arrive in a week. So when I get them, I'll probably put them back, see if they work. But in the meantime, this actually works, so I'm inclined to just leave it alone. I'll neaten it up a little bit and see how it goes like this. The other issue I've got, and I don't know if that was it's a problem with the pot or what, but that's minimum volume.
Just a part of her story.
It doesn't go any lower than that. Certainly goes higher.
A negative story. This was a positive story, and capturing our elders. I think that's been a big part.
And it could be because these two little fellas have a bit too much gain. I could probably compensate by putting a resistor in series with the pot or something. I can fiddle with that. I'm sure we can get a result with that. Well, I'm going to leave it here. This was going to be a simple one-part video, but the best laid plans, as they say. And I'm off on a road trip for a couple of weeks up north to Exmouth and Ningaloo Reef. So the rest will have to wait till I get back. Ironically, my germanium transistors have just arrived, but I won't have a chance to do anything with that before I go. So I'll be back in a couple of weeks with part 2. We'll finish this off, do the case, get everything sorted out, and then I've got any number of other projects to get back onto, a shed full of radios to fix. So thanks for watching. We'll catch you in a couple of weeks when I'm back. Bye for now.